Okay, good morning everyone. Today we are working on, again, something slightly new. We always do something slightly new every single day. And we're going to move on from exponents to adding polynomials together. We're going to add polynomials together. So what does that look like? So what is a polynomial? Well, what we've been working on was are pretty much x values. X plus 2, okay? And if I ask you to add x plus 3 to this, these are what we call polynomials. But this is like the easiest version of it. Now, when I'm adding x plus 2 and x plus 3, we want to figure out a way to make this make sense in our brain. And the idea is when I'm adding group 1, you can call this group 1, to group 2. Whoops. Right, I'm adding group 1 to group 2. We're going to combine, like what we did before, like terms. We're going to only combine what we deem are like terms. And what's a like term here? Well, x's are like terms, and the 2 and the 3 are like terms. Constants are like terms. So what is an x? An x, remember, is a variable. It stands for a number. So if I say I have one x and I have another x, well, how many x's do we have now? Well, we have 2 of those x's. Let's just write 2x. What happens to the 2 and the 3? Well, 2 plus 3 is 5. So when we're combining like terms here, we're talking about terms that have the same type. X's with x, constants with constants. You can't combine 2 and the x together because these aren't like terms. Why can't we combine them? It's because we don't know what x is going to be yet. If I say x plus 2, why can't we say this is 2x? Because this means I have 2 x's over here. And unless if x is going to be 2, x plus 2 is not the same as 2 x's. X plus 2 is not the same as 2 x's. So they're not the same thing. So what we say is, if I add x plus 2, and we've seen it before, x plus 2 is just x plus 2. We don't touch it. Now, if I go ahead and give you another example of more like terms, if I say 3x plus 2 adding to 5 plus 6x, if I'm adding these terms together, we're only combining like terms. Well, constants with constants and variables with variables. In this case, if I have 3 x's and 6 x's and I add them together, I'm going to just rewrite it right now so you guys can see it. 3x plus 6x plus 2 plus 5. I'm moving the like terms near each other. Well, 3x plus 6x is I have 9 x's. And 2 plus 5 is 7. What about if I kick this up a notch? What if I say x squared plus 3x plus 2 plus 5x squared plus 6? I have 2 groups here like what we did before. In these 2 groups, we're going to add our like terms. Now let's see if you guys can add the like terms. I'm going to give you guys 30 seconds to figure out which are the like terms and then combine them and give me a final answer. Okay, hopefully you see that the x squares combine and the 2 and the 6 and the 3x here do not have any like terms, so we can leave it alone actually. So we're talking about x squared plus 5x squared is 6x squared plus 3x plus 8. Now let me give you a way that we've actually seen this before. If I look at this as numbers, what if this was 132 plus 506? Okay, 132. How did I come up with that? What if I told you x was 10? if x was 10, that would be 10 times 10 is 100. 10 squared is 100. Plus 3 times 10 is 30 plus 2. That's 132. 5 times 10 squared. 5 times 10 squared is 5 times 10 squared, which is 100 plus 6, 106. And how do we normally add 132 plus 506? We add the hundreds, we add the tens, and then we add the constants, the last numbers. And it's nice to see if it's 10, but what if it was 8? What if it was 7? What if it was 6? And what happens is, when we're combining like terms, we don't want to mix up our different exponents because they're different types. X squared and x are very different in the numbers that they result from. Right? Isn't 10 squared very different than 3 times 10? That's 130. These aren't like terms. But 100 and 500, these are like terms. So we can combine those. All right. So we're going to look at our homework today. And this is like the idea of adding, but they want us to look at it also differently. You guys might have seen this in junior high where it becomes algebra tiles. And the reason why they show things in the form of algebra tiles is because they really want to emphasize that x squared and x are two different things. X squared and x are two different things. So let's take a look here today at our, whoops, that's something else. We're going to Excel, and we're going to jump into, let me pause this for a moment. Okay, so I'm going to teach you guys right now, if you guys haven't learned how to read this yet, these are what we call algebra tiles. And if maybe in 8th grade or 7th grade, you guys have seen these little squares and you guys would mix them around. And the idea here is to represent each of our polynomial terms in a shape, okay? Now if I see right here, I see x squared, and x and a 1 and a 1. So if you look here, I have x squared, and x and a 1 and a 1. So I want to ask you, how many x squares do we have? We have 2 x squares. So we have 2 x squares. That's really what they want you to write. How many x's do you have? You have 1x. So I'm just going to write x. You could write 1x, but we always just write 1x as just x, meaning the 1 is invisible. How about the ones? Well, how many singles do you have? You have plus 2 singles. And that's how they want you to realize this. They want you to see that, okay, x squares are different than x's, and x's are different than constants. Okay? It's that simple. It'll take you a couple of minutes, hopefully, to crack the code. But that's all they want you guys to figure out right now. And I want to make sure you guys are cool with this. This idea of that these variables are different and they weigh differently. Where x squares are x times x, which is different than just a regular x. Let's use the number 3. If I say x squared plus, x squared plus x plus 2, and let's make x equals to 3. Well, what is 3 squared? Isn't that 9? And isn't 9 different than 3? What if x was 5? That'll be x squared plus x plus 2. That'll be 5 squared. What's 5 squared? 5 squared is 25 plus 5 plus 2. So giving you these two examples here, x squared and x gives you two different results. X squared and x gives you two different results. That's why we cannot combine them. We can't say x squared plus x is 3x cubed, or however you want to write it. That doesn't give us the same results. That is not the same as 9 plus 3. It's almost like me saying first graders and second graders. Are first graders and second graders the same thing? No. So we can see these are first graders, second graders, and these guys are kindergartners. So all they want you to do for our first IXL practice is really simple. Just write out what you see by the tiles. So our first problem is going to be simply just 2, we set x, and we hit the square button here for exponent, tap out, it's faster on your keyboard, plus x, and then I have positive 2 here, plus 2. Okay, that's all they wanted. I want you guys to try to figure out what this would be. Okay, I want you guys to figure out right now what this would be. I'm going to give you guys about, let's say, 30 seconds. Okay, 30 seconds. Okay, 10 more seconds. All right, let's see. How many x squares do we have? We have, I'm looking here, I'm seeing we have 1, 2, 3, 4x squares. Okay, so I'm going to type here 4x squared. All right. How many x's do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 x's, all right. Plus symbol, 10x. This is so much faster if you just do this on a computer. And how many singles do we have? I see 1, 2, 3, 4. And all the skill is to allow you to see, hey, x squares and x's are different. Right? So you do that for a little bit, only up to 50. Our next one we're going to work on is adding, whoops, what are you doing here? We'll be adding and subtracting using algebra tiles. Right. So for this problem here, you're going to add the first group plus the second group. Now, this isn't super hard because we're just combining items that look alike. I have x squared. Any x squares here? Do you see any x squares here? You see none. So I have 1, 2, 3, 4, 5, 6 x squares. 6 x squares. How many x's do we have total? 1, 2, 3, 4, 5, 6, 7, 8. And I'm adding a ninth one here. Remember, we're combining like terms. 9 x's. And how many singles do we have? 1, 2, 3, 4. 5, 6, 7, 8, 9, 10, 11, 12. It's almost like a family get-together. All the old people hang out, all the kids hang out, and all the toddlers are stuck in a room. And this is all they want you to do. That's how heavy this practice is today. So we have 6, darn it. No. Okay, we have 6x. You know what? You guys don't need me to receive me right here. Let's go ahead and just move on to the next question. Okay. So we're going to be subtracting here, but take a look here. These are shown in red and they're negative. And they even told us what this looks like on top. So we're subtracting negative 10x, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 7, 1, 2, 3, 4, 5, 6, 7. And we're going to combine it by subtracting with negative 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6. So negative 5x squared plus 6. Now, algebra tiles, I don't feel like it's helpful here, but we can still see that we're combining x squares with x squares. But I actually find it's actually easier to just look at the equation form of this. Now, here is the rule. Remember, if we are minusing, we have to distribute the negative sign. Okay, we're minusing everyone, so I'm going to minus that parentheses. So I'm going to distribute the parentheses. So it'll be negative 10 x squared plus 7. What's a negative times a negative? That's a positive 5x squared. And what's a negative times a positive? That is a negative 6. So when I'm minusing the second group, we have to flip the signs. So this becomes negative 10, and 5 is negative 5x squared. 7 minus 6 is plus 1. Negative 5x squared plus 1. Okay, we're still combining like terms, but if I'm subtracting, remember we have to flip the signs. And one of the things, critical things, is you have to remember to flip everyone in that parentheses. Let's try another problem like this, similar. Negative 5x squared minus 10x, and we're going to make everyone here negative, right? So we're going to flip the signs. A negative times negative is a positive x squared. A negative times negative is a positive 8x. Okay, now we can combine like terms. A negative 5x and a positive 1x. Negative 5 plus 1 is a negative 4x squared. 5 minus 1 is 4, negative. And the 10x and the 8x, these are like terms. Negative 2x. Okay. Now the algebra tiles there, again, are just to show you the grouping. I have 5x squares and I have 1x. And if we're subtracting them, hey, shouldn't we have 4 left over? I have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if I'm subtracting 8 of them, 1, 2, 3, 4, 5, 6, 7, 8, lost one, 8, we should have negative 2 left of them. Okay. All right. I personally still find, though, us working with the actual equations to be the fastest. But we're going to go ahead and look here. Let me see. How come this is the first time it never went away? Just go ahead and add and subtract the polynomials now. So if I'm adding group 1 plus group 2, just this is back where we started from. Combine like terms only. I'm going to combine the 4j squared, 4j squared, and the 6j squared. Well, 4 plus 6 is 10j squared. Adding is always easiest. I have 1j here. Hey, I also have j's here. 1 plus 4 is 5j's. And I have a 3 by itself, plus 3. Okay, let's try the next hardest one. If we're looking at subtraction, we're going to subtract group A from group B. But we can, when we're combining, we're only combining like terms. So the 4 and the 3 combined, the 2 and the 3 and the 2 combined. But careful, since we're subtracting, I'm going to rewrite this as 4p squared plus 3p plus 5 minus 3p squared, because a positive times a negative is a negative, and then a negative times a positive is a negative also. So once I distribute that negative sign, this problem can be just combined. 4 minus 3 is 1p squared. 3 minus 2 is 1, right? 3 minus 2 is 1. And we're left with a constant of 5. Okay, that's it.